Hi there, folks, and welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk all things cloud. Now, we're going to be talking, I guess, evolving some discussions that we've already had on the channel before. We think about things like resilience and performance and scalability as part of the applications and solutions that we build day to day. But as consumers, as users of applications, we're getting more and more demanding of those applications. We want them to be up 24/7. We want them to be responsive. But as designers and developers and creators of those solutions, how can we make sure that those things are resilient and built in a way that they can scale before there's a problem? We're going to be talking all about chaos engineering, some of the tools that are out there, some of the maybe tips and tricks that you might want to think about as well as you're using these. Like, when is the right time to go and use it? How do you adapt it and adopt it into your life cycle as well? So with that, I'm very pleased today to be joined by Ashish Balgat. Hey, Ashish.
Thanks, Chris. Thanks for this opportunity. It's honor to be on this show. Been always looking forward, listening to your videos, and great to be here. Thanks.
Awesome. No, thank you. And I know we've tried getting the scheduling on this one a few times, so I'm glad we've finally been able to make it work as well, because this is such a super interesting topic to me. I've always been interested in, things like unit testing and how we make sure we can test for quality. But this goes a level further because this isn't like a yes, no kind of test like with unit testing. Like, this now goes to our business requirements and to some of those other requirements that help us determine, is the application going to work for those end users?
Yeah, absolutely. I mean, there's a different mindset required to kind of
Mm,
test this kind of applications. I mean, we are in a distributed world, and failure is gonna bound to happen. I mean,
yeah, for sure.
something or other is gonna fail for us, and how we adapt to this failure in this distributed world, I think it's key. And chaos testing is just, I would say, chaos engineering just kind of a name. We've been doing this in the past as well. I mean, if I remember way back when we're doing on-prem application, we used to plug in the network cable and see
Yep.
uh, cache working, things working. We may not formally do that in a structured way,
Yes.
but we had some kind of testing doing in pulling out the network cable and see uh, clicking how things respond to it. I think that's probably the beginning in the I would say early 2000 I would say areas, and then when cloud evolved, distributed systems
Yes.
evolved, when you get into this microservices world, it's a nightmare.
Mm,
it's and
it's
this is
funny.
yeah, this
It's
is where
funny. As,
you
yeah.
need some kind of this structured, controlled testing, kiosk,
Mm.
and I think this is right time to talk about it.
Yeah, of course. And it's funny, as you were kind of explaining in the beginning and talking about the heritage of where it's come from,
Yeah.
um, my mind immediately went to the thought of that person behind the server ready to pull out the power cable to do the check, if this instance goes down, how does the application continue?
Yes.
So exactly the same with network cables, caching servers, etc., all very relevant. So before we jump into any of that, we should probably start with introductions as well. So, who are you, Ashish? What's your background? And I guess why the passion on this topic here as well?
Sure. Thanks. My name is Ashish. I've been with ThoughtWorks for last 2 years. I've been with industry for 16 years building distributed applications. I've spent a decade on cloud, especially on Azure. Lately,
Mm,
I'm working on GCP and AWS as well. I'm
sure.
playing a cloud solution architect role at ThoughtWorks, and my role has been to work with different customers. I kind of help them in architecting resilience applications. I think scalable applications. I think all the elites coming from Milford and Mark Richards. I think those are critical there.
Hmm.
And resiliency, reliability is one of them. And focus on that topic. I think the journey started probably a year back when I got introduced to this chaos engineering while I was kind of building a distributed application. I
Mm,
ran a couple of cloud native tools, and I just got excited. though I've heard of this concept probably 4 to 5 years back in one of the AWS conference where they introduce some of their fault injection simulator tools and all those things. But yeah, I dirt my hands probably a year and a half back when, and I'm just got passionate at reading more about it, understanding different nuances when you can do it. It's a different ball game.
Mm,
So, but
sure.
it's very critical. So that's
Gotcha.
that's my journey on chaos engineering. I've been speaking
Super.
in multiple conferences. Recently, I spoke in Developer Week in Austin on the same topic. Then I think I spoke in SRE Day at London as well.
Mhm.
And I think that's more and more you get into this topic. I think you research more and you get more passionate. So that's how it had been. I'm glad I'm
Go
here
down the
again.
rabbit hole.
College.
Excellent. Excellent. No, thank you for that. And yeah, I guess we've already kind of established here, I suppose, what chaos engineering, chaos testing is. It's that idea of almost making chaos something that we can control, making it almost like an experiment. So, we can say as part of the process to releasing to production, we have to try run at 50% load. We have to try and do a certain kind of scenario. So we're testing for those different ilities, as you said. So reliability, scalability, etc. So, um, where do we start, I suppose? Let's say I understand the concept. I understand broadly what we're trying to achieve, but now I need to figure out how to get started, how to like actually build this into what I do day to day. Where do we go from here?
Yeah, I mean, the multiple entry points, I would say. Most of the people, I mean, when they heard chaos engineering, they always think we need to run some kind of faults, inject some kind of faults in on production environment. Yep, that's true. But
Mhm.
that's not the only place I would just recommend. I mean, we can do start that early in our cycle when the system is kind of mature. I mean, you can't start from the
Mm,
day one. You have to spend time doing that day one, but until your application is mature, you have a great observability, you have great health check systems, you have great logging infrastructure, you can debug your distributed application. I think that's where you should get into um, chaos engineering. I mean,
mm,
chaos engineering is more kind of proactively testing for the failures happening in production, right? It's proactive what is important. I kind of synonym chaos engineering with the fire drill. Uh, when the way they kind of work is they work in a controlled fashion. 90% of
mm,
time they do the drills in the controlled fashion. They kind of make sure their muscles memory, they know what exactly needs to be done when the unfortunate incident happens. And when it happens, they just don't apply their brains because you can't apply brains at that point of time. You just
Nope.
go run your SOPs, run your standard operating procedures, and kind of recover pretty fast. I think if you can analogy that to chaos engineering, I think something similar.
Mm,
Uh, you practice this in your control environment.
mm,
Definitely, production environment you should do it. That's where you will have the exact data set, exact access control policies, exact customer load. You're gonna find it. But I would say I've seen this happening. I think you can do this in early part of your development cycle as well. I mean, when you are in your QA environment or pre-prod environment, you can
mm,
do developers these days. These I'll talk about a couple of tools, the cloud native tools. It's easy for developers as well
mm.
to run uh, kind of run these tools on their developer machines as well and kind of
Sure.
test how the system is behaving in if there's a load or if there's a CPU. 50% is the auto scaling happening.
Mm,
If right region is down, if there's one region failure, if is your application reading from the other region. So I think this can be done in, I would say, pre-prod environments as well, maybe QA environment and definitely staging environment.
mm.
And yeah, at some point of time you need to run in production environment. No doubt about
Understood.
that.
Understood. So effectively, then it's something that helps us, as I mentioned earlier, control the chaos, understand certain scenarios, so that as we're releasing our application to production, we can be sure that, well, not sure necessarily, but we can increase our confidence
Yes.
that we're going to be able to handle certain scenarios. Now, I liked what you said in there because, there's that shift left mentality. I guess I
Yeah.
mirrored shift left. There we go. We want to be able to bring that into dev to QA potentially. And it's not necessarily going to be the same thresholds because when we deploy our dev and QA environments, rarely are they an exact copy of what is in production. So we'll have to kind of, I guess, level out and play a little bit with what we're testing there. But as you say, by the time we get to production, ideally we want to have gone through some kind of production-like environment, tested everything, including policies, including everything else, that we can operate in the manner that we want to. And it's so important because I've seen so many occasions where people will do these kind of tests and they'll either change the test, they'll change the environment, they'll change the underlying configuration of the infrastructure, which is okay, but you can't be sure until you've run it on something which is like a replica of that environment. All you need is one configuration change on your infrastructure to be out, and then it doesn't scale as you think. And I think this is the beauty of the world we're in now with cloud, where we've got this infrastructure as code we can work with. We can have these dynamic environments. So if I do my production release, I just add a step beforehand, deploy that production-like environment, deploy, run the scale test and the performance test, check everything works okay, great, and spin it all down and delete it, and off it goes to production. And that's a really nice kind of way of working that. You've got that quality, you've minimized cost, and at the same time, you've been able to check for the quality there as well.
Absolutely, absolutely. And one couple of things we need to keep in mind is, I mean, I would say, I think the chaos engineering is one portion of it, building your
Mm.
resilient apps. I think architecting resilient apps is another important piece. I think
Oh,
the solution
yes.
architect, the cloud architect, the enterprise architect should think
Yes.
of building resilient apps from the beginning. I mean, take an example of architecting application resilient pattern. There are a lot of application resilient patterns like circuit breaker,
Mm-hmm.
retries, bulkhead pattern. Um, so these are the patterns you should bake in your application. You most of your distributed application interface with external parties. I mean, they're gonna make a REST API call, or they're
Mm.
gonna make an, I would say, a service call as well there, and they're bound to failure. So how your system, how your application is handling, I think you should bake those resiliency from the beginning.
For
Architecting for
sure.
resilience, I would say, that's an application level resiliency. Then comes the infrastructure level resiliency. Okay, so
Mm.
build a redundancy, backup, uh, multiple region deployment. If one of the region failures, how you gonna make it? Caching. I think this architecting application resiliency pattern, infrastructure resiliency pattern, that's the first step. You should do it. You should bake in. I mean, generally we think it's a tech debt. We'll do it when it fails in production, but I would say we should start doing that upfront, and then we introduce kiosk testing to
Mm.
proactively test whatever you have implemented.
Yeah.
And I think that those are the key areas as well where should we should begin. And it's developers, architect, um, everybody in the
Mm.
team should focus on that aspect as well.
Yeah. No, for sure. It's everyone's job, isn't it? Because um, without implementing those patterns, if there is that failure, then you haven't got anything to fall back on. If you're not
Exactly.
retrying, for example, then that message is gone. That message has disappeared potentially. If you're not doing a circuit breaker, then just doing a dumb retry alone, are you potentially just exacerbating the problem because you're sending more loads to another downstream service, right? So there's many challenges here, and it
I
all
mean,
starts with good architecture. Spot on.
yeah, I mean, generally, this, if you start blindly with chaos engineering, then you probably gonna go back and bake in this kind of patterns in your code. But I would say you
Mm,
should start doing that and think of that as an important thing. And there are a couple of tools now. I mean, I'll jump into
mm,
the at some point of time, but one of the
sure.
uh, two of, I would say, each of the cloud provider has their own tools.
Mm,
Azure has Azure Chaos Studio. I think that's still in preview. I think it's been probably a year now. It's in preview, so we should expect any time in GA now. And there's another one which kind of got I would say more eyes for me. It's AWS Resiliency Hub. I think
Mm,
it's more on top of injecting failure. So Azure Chaos Studio, Chaos Monkey. I'm sure everybody heard of Chaos Monkey from the Netflix. It's an open source.
mm,
Gremlin. These are tools which kind of focus on injecting failures in the environment wherever you run it. Okay, and there are
mm,
different kind of failures: CPU load, latency, pod crash, um, firewall rule blocking. I think there are a number of rules you can apply. Okay, so these are
mm.
specialized tools, and you're gonna find a lot of community driven plugins on top of it which you can leverage it. Okay, so this is
Sure.
great. AWS Resiliency Hub has been one step ahead. What
Mm,
they do is not only they provide this fault injection simulator, but you can define, you can start architecting your resilient apps from the beginning in the AWS world.
mm,
So you basically define your RTO, RPO. I'm sure it's recovery time objective, a recovery point of those are the kind of measures for your resilience application.
sure.
Um, you can define that upfront for your application, RTOs and RPOs, and then you can inject this fault injection methods in
Mm,
your, can it be all automated in your CI/CD pipelines. So the moment you check in something, you release a feature, you run the CI/CD pipeline, you validate your uh, application and the infrastructure patterns. I would say
mm.
resilient based out of what you have said for RTO and RPO.
Nice.
And AWS Resiliency will give you a resiliency score. Similarly, we
Mm,
have heard of security score. Um,
mm,
you have 83% security, 80%, 85%, you need to reach 100%. Similarly,
mm,
AWS Resiliency Hub, looking at your policies configured, looking at your experiments, what you have run, it will validate and it will give you a resilience score, which you can track it and continuously try to improve it. It will
mm,
also give you recommendation, alarms, SOPs, which you can go back and apply those in your infrastructure resiliency patterns or application resiliency patterns. So
mm,
it's not only a chaos engineering tool, but I
mm,
would say it's an entire package of continuous
mm.
resiliency. I mean, we have heard CI, we have CD. At some point of time, I'm sure we're gonna hear CR as well, and which is AWS Resiliency Hub, and there are a few more tools. I mean, one of them which is very promising is StudyBit. They are also kind of coming up with something similar concept where
Mm,
you want application posture, I would say, uh,
mm.
resilience posture of your application. Uh, keep on measuring and keep on tracking and kind of build it. So
Gotcha. But there's
interesting.
something really, yeah, there's a really important theme in everything you've said there, and that is this idea of iteration, this idea that we don't have to kind of fix resiliency and then it's done. There's always something that we can change, we can fix, we can improve on. And I like the idea of using some kind of score as the baseline to track that over time and then keep improving on that. Um, it's particularly important because I think there's sometimes this mentality that you architect a solution for that initial go live, or at least this is a perception I see a lot. You
Mhm.
architect it for that go live, it's done, and then it's like, okay, that resilience, performance, etc., is no longer something which is as important. It's then just a feature update and all these things, but keeping that on mind all the time, it's something that can degrade over time. Like if you bring in a new feature, maybe it's not as performant, it doesn't bring in those application patterns you mentioned, or equally, you know what, maybe we have got some technical debt. There are some things that don't scale as well, or there are some things that don't perform, and that's okay. Maybe we've got other problems right now, or other scenarios that we want to focus on right now. That's equally perfectly okay. It might not be the most important thing because we equally have to be very realistic that we're never ever going to have a system which is 100% foolproof. It's not going to be 100% secure, 100% resilient, 100% scalable, 100% all these different ilities because everything is always moving. The challenges are always moving. The technology is always moving. the solutions we're building are always moving. But having that mindset where we continually keep improving is okay. We're that's exactly why we do this, I guess.
Yep,
Yeah.
absolutely. I mean, just and I mean, there's definitely a culture change here. It's a mindset.
Mm,
You brought a right point there. I mean, as you rightly said, I mean, we'll do it once and we say everything works fine, great. Our architecture is resilient, but I mean, it's evolutionary. I mean, we have heard of evolutionary architecture. It's evolutionary every time you build, you add some more features on your application. You ensure that your baseline is maintained. You're not kind of gone back and
mm,
keep on doing where you can. I mean, it's important to do that, and this continuous resilience is one way of doing it. Resilience is core. I mean, but yeah, I would say it's a total mindset change. It's not kind of fun. It's a collaborative effort again, as a team
mm,
effort. I mean,
exactly.
I'm sure you would have heard of game days as well.
Yep.
People used to run game days, and I was part of one of the game days as well. It's not a blame game, I would say. I mean, one
No.
point of code is impacting the stuff, but it's together as a team, identify that problem, fix it, and make it your application much better and better. One another thing, I mean, chaos engineering definitely build help you in your application resiliency, infrastructure resiliency. But one more important thing I would say, side benefit of chaos engineering, running this chaos engineering game days is your team getting empowered to look at logs, debugging,
Mm,
and production issues. So I'm sure when we have this 3 nines, 4 nines, 5 nines, the error budget is very low. Okay,
mm,
so I
yep.
don't remember the exact for 3 nines, but it's less than 60 minutes a year.
Yep.
Uh, if there's an outage, and if you just look at trying to trace the logs, you have not seen that kind of outage before, and you have not simulated that kind of environment, you're just gonna shoot up your error budget, and
Yeah.
it's very less. I mean, so to achieve again those 3 nines, 4 nines, it's important to you practice this. I mean, you should have
For
those
sure.
muscle memory of debugging stuff, your standard operating procedures. You could pinpoint, troubleshoot the problem pretty fast, fix it. Ideally, it should be automatic failover to another region if things goes down. So all those complexities should be uncovered um,
Mm,
during this chaos engineering tools early in the cycle, as well as on the production environment. So
yeah.
it's important to do it. And I just want to summarize them. It's not only the benefit from an architecture point of view, but the team collaboration, the
Indeed.
culture fit, and improving your team's debugging skills when
Mm.
this outages happens. I think this all benefits to entire
There's a
team.
Yeah, there's a couple of points in there as well to really pull out. I think one is exactly as you say, there's that team element, and I think it's really worth us adding that we mentioned about things going on the backlog in terms of issues. A solution perfectly could be, you know what, we've got this monitoring script that helps us detect if that issue comes up, and we've got some playbook that can be operated by someone and done within 5 minutes. Like, if that's acceptable, then okay, that's a solution. And that leads me to my second point, which is we're kind of talking in terms of the higher end of the spectrum here, or higher end, there we go. Need to remember I'm backwards on this screen. So on the higher end here, um, some applications might not need that level of architecture as well. They might not have super high resilience requirements or super high scalability requirements. So in some cases, it might be overkill and the wrong thing to invest that amount of cost and complexity in that as well. So there's always got to be that kind of level-headed trade-off as well there, I'd say. So so good. So we've established what it is. We've established why we'd want to kind of use it and consider it. And we've talked about maybe some of those scenarios where even it can help the team, etc. I think you mentioned you had some demos potentially or something you wanted to walk through.
I think I can. Yeah, I have kind of planned for a demo where we're
Yeah.
gonna test the um, disaster recovery. I think
Mm,
that's one of the very tough thing to record, because you don't see a region failure very often.
mm,
But yeah, in the past we had one with AWS.
mhm,
I remember I don't remember exactly when, but there was a hurricane and one of the region
Sure.
in US, I think the AWS region was down and it was impacted.
Mm,
So yeah, I mean we can test it out and we can see. So let me share my
sounds
screen.
good. Sure. Yeah. If you want to move across, and I can bring that up for you.
Yeah, please. Let me know if you can see my screen.
I can. Thank you.
Great. So let me show you. So this is in Azure. I'm using the Azure Chaos Studio.
Sure.
So I'll just jump into that. Before I jump into this, is a simple kind of an Hello World application. I would just say it's deployed into two VMs, virtual machines,
Hmm.
and we have a traffic manager, which is kind of a load balancer, which accept the incoming traffic and kind of redirect to one of the backend pool. So we have
Mm,
two virtual machines where things have been deployed here. We have a traffic manager, and then we have a kiosk experiment. I'll get into that, but before that, I'll just show you how this application looks like.
sure.
So I'm going to do the okay. So this is it's just basically kind of ping to that server. So this is the traffic manager profile URL,
Hmm.
and if you say it's in kind of a round robin fashion, it's gonna right now it's responding from a server too. So one of the
Hmm.
VM is deployed in, I would say, West US, and the other is in the Azure paired region is East US. So server one is in East US, server
Hmm.
two is in West US,
Sure.
and I think it's randomly, maybe it's caching right now, but it's gonna jump to one or the other one. Right now, it's jumping on the server two only, but that's
That's
fine.
okay.
Yeah, so let me show you Azure Chaos Studio, what exactly this is. This is one of the tool, the cloud native tool. You can use it. So
Mm,
you can, as I said, I mean, there's so many tools available. Uh, but one of the advantage with leveraging cloud native tools is they have those configuration to manage services. So I'll show you a couple of them. So this is an experiment, and so you can basically create an. Let me go from here. So this is the Kiosk Studio. Is it visible? Should I zoom it more?
that's good. No, that's okay. Thank you.
Okay. Okay. So this is the Kiosk Studio icon. You're gonna see it's still in preview, so I won't recommend that. But you can always run that in dev environment. Uh, these are the targets. So first, you need to kind of add your targets on which you want to
Mm,
run your kiosk experiments. So
hmm.
basically, you want to see virtual machines, the AKS clusters. I've been doing a lot of things these days. So
Hmm.
NHGs and all those things, targets are kind of configured. And I have multiple experiments, but I'll have an AKS. I was able to pod crash and see the self-healing works. Then
Mm,
Cosmos experiment where Cosmos DB had this multi-region write. So I was able to fail one of the region, right region, and see still able to read out of it. This is one I wanted to show you right now. It's the traffic manager, which is kind of a disaster recovery.
sure.
So as I said, we have application deployed in two VMs, one deployed in East US and the other one in West US, and assume there's an Azure outage happening on one of the region.
Okay.
Your application should be still responding to your customers. I think that's the important. So
Mm,
uh, these experimenters are pretty straightforward to write, I think. And first of all, you can definitely do this portal, but there's also an infrastructure as a code, CI/CD
mm,
integration available with um, Azure CLI with this Kiosk Studio. Also REST APIs as well. So you can
mm,
there are three portal CLI and REST API kind of interface to automate these experiments.
gotcha.
So what I'm doing right now is so these are the steps which kind of run in sequential. So you can add multiple steps. I've just added one step, and the branch are kind of you can run in parallel. So what I'm doing
Mm,
is region failover. So I'm stopping the server one, which is running in East US.
hmm.
So I'm kind of abrupting that VM shutdown for 5 minutes, and all the user traffic should now go to server 2, which is in West US.
Mm,
Okay, so that's kind of an experiment, and I just want to show you so you
there you go. Yeah.
so see the faults, the different kind of faults, and
Yeah.
one of the reasons why I'd said is one of why we should go with
Ah,
cloud native tools is uh, they have, you can inject the faults. You don't need to run agents always. So they have both agent and
Mm.
agentless. Agent is when you have virtual machines, infrastructure as a code, where infrastructure as a service, I
Oh.
would say, where you need to install agent and kind of run this. But if you are using managed services out of box, um, this these are the faults which gonna get added. So if you see Cosmos DB failure, it's a managed service, and it provides you that failure fault. You can inject and failure in Cosmos DB and see you can still read from the another region. So you have a CPU pressure, disk IO, you can kill process, you can AKS pod crash. I would say there's also a latency which you can add, delay
Mm.
basically. So if you're making an external API call and if you want to test your circuit breaker or and retry is working fine or not, you can add that delay and you can see in the logs how many times it retries, did it retries in the right fashion. So you can basically test uh, uh,
Mhm.
your
Just
application.
different aspects. Yeah, I'm with you. Understand.
This is
Good.
another one, firewall disconnect, and this is one of the many cause I would say. If you remember last year, we had an 2021 outage and AWS during the Black Friday, and one of the reason was they had some change on the network configuration, which caused that basically the problem. And I think you can simulate those kind of behavior. Hardware are bound to fail. So if there's some network firewall router failure happening, how's your application responding to those kind of failures? I think it's
Mm.
important to test all those scenarios. Okay, so I'm doing the simple one, which is VM shutdown. I'm shutting down for the 5 minutes, and what I'm gonna be doing is all the traffic should go back
And
to,
just playing devil's advocate here, so given we've seen that server 2 was the active one, can we
yeah,
change the experiment to shut down server 2 instead to see if it
yeah.
swaps
That's a
back
good
to
thing.
server
That's a
1?
good thing. Let me see if this is still on server two. Okay, this is still on server two. So let me change that. That's an interesting thing, and like it's
There you
pretty
go.
easy to change that as well.
Yeah.
So bear with me. I think okay. Stop server one. So instead of that, what I'm gonna be doing here is I'm gonna go edit and
I think
VM
at the bottom there
shutdown.
you've got target resources there. That's it.
So rather than doing the one, what I'll do is now I'll do this.
Mm.
Okay. So let me save it and I'll just change this to this so that I remember that happening next time.
Yeah, exactly. There you go.
Save it.
Nothing like live demo changes and
Yeah, that's
people
I'm
making a change.
just now, so right. So let me see if thing is still on server two and great.
There we
So
go.
now I
Still
can start
there.
my experiment. This is still in preview, so the pricing and things gonna come in
Mm.
picture at some point of time when it gets GA. But I assume it's
Sure.
gonna be free for use. So the time your experiment is running, it gonna basically get deployed this kiosk, agents, studios, and some I would say internal containers or serverless containers. I don't know exactly where it's running now, and you're gonna be paying for the time you run these experiments.
Mm. Gotcha.
So it's
Gotcha.
kind of getting similar to an build agents when in your Azure DevOps as well. So it's waiting to start. It's kind of looking for some of the compute available. Once it
Mm.
gonna assign experiment to that compute and it gonna run. Meantime, what I can show you guys. Okay, uh, let me show you some the other stuff. So this probably gonna take a while.
Mm.
So let me show you. So right now you see these two VMs.
Hmm.
So this is the second one VM which we are kind of shutting it down. So they are both kind of running right now. Oh,
There
this
we go. It stopped. Yep.
already stopped. Okay, this is running, and this is stopped. So I'm sure I think it got the agent and yeah, it's running. Okay, so
Yeah.
now we go back to the traffic, and the hypothesis is your application still should be able to respond.
Yep.
Uh, uh, so the server 2 is not responding, it's kind of cached. Now you open another
Mm.
window, and hopefully it should. bump to server one. That's what the chaos is all about. Uh, I will show you another thing. I'm sure. I think it might take some time to respond because of the caching stuff. But
Mm.
you look at the traffic manager.
But this is exactly the point of the chaos testing, isn't it? Is to check that
Exactly.
this type of thing
Exactly.
um,
See
is a
you back
challenge
in.
not in production. Yes. Yeah.
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 It's gonna take some time. So right now both are online. So it is an health endpoint, which kind of runs ping
Yes.
the backend pool. So right now it's wait 1 1. At some
And
point of time, see this is
there
degraded.
you go. Exactly.
This is
So now
degraded.
if you go back, it should
Now if I
route
should
to
go
another
back,
instance.
yeah, it should. It's taking some time, but
Mm.
I'm sure it's gonna go to server one, and this guy will not respond. So yeah, so this is degrading. I think it's the switch over is happening in traffic manager as well, and it will basically go to these things. And meantime, this VM is still running, and this is for 5 minutes.
Mm.
Yeah, the VM is stopped. So this is what exactly is your hypothesis. You need to define your hypothesis when you run chaos experiment, and you validate. You run your experiment, you validate it, and most important is you roll back. Okay,
Yes.
whatever chaos you have introduced, you need to roll it back. So this is what this tool gonna be doing at the end of it. So whatever we have just introduced 5 minutes VM, you can have a bunch of chaining of process. It's gonna roll back to the original state. Uh, Else you're gonna just finish up your error budget.
Mm. Understood.
Yeah,
Yes.
finally.
There you go.
So,
There you
and
go.
so the hypothesis is getting validated here. Your customer is able to respond. There was some downtime here and there, but you were able to recover it pretty fastly. And
But this is exactly the purpose of this type of test: is you can then figure out, is an instance in each region enough? Do you need some scalability or resilience, like even, what am I trying to say? High availability there as well, in terms of like load balancing within region, and what are those different scenarios that you're testing for? And this gives you that way to experiment with that, which is nice.
absolutely, I
Very
mean,
good.
this is, and there's a lot of power in this tool. I mean, it's not only this is the high availability test what we do, but latency, as I said, increasing the load on
Mm,
CPU load or the pod load, and see how is that service behaving. uh, in the real world this may happen. I mean, one of your services overloaded, overwhelmed, and it should not cascade failures down for the other services. I
exactly.
think you can test it out upfront, and this can be done in developer environment as well. I mean, yeah, definitely you need to do in production environment. I'm not saying that, no, but I'm sure developers will get a lot of value by running these experiments and seeing how your services are behaving,
Mm,
and architect for resilient, I would just say.
gotcha. No, good. Thank you for the
That's
demo.
probably what
Appreciate
I had in the demo.
it. No, it's all good. I appreciate the demo. Thank you. So, I guess as we kind of start wrapping up here, we've gone from talking high level around what chaos testing is, and how we can bring that into the workflow, different ideas in terms of how we can use it maybe in dev or even on our local machine, and thinking forwards to like that path to production. Um, how, if I'm someone who's kind of listened in here and thought, okay, this all makes sense, I see the value, I need to get started with this, I need to try it out. What would be your recommendation? Like, do they kind of pick a project and start small? Maybe what are their like few tips to getting started with this, I guess?
Yeah, I would definitely give that tip. Before that, I just want to make one point here is,
Mm,
um, I've seen in large organization. I mean, we work with a lot of customers. Chaos engineering kind of still a naive word, but with large enterprise, I think you talk about Amazon, you talk about Microsoft, you talk about Google. I think these are well established practices. They have
mm,
a centralized team running this. If you see SRE book, I mean, one of the favorite book I have read is the SRE book from Google. and they have a dedicated team to run this kiosk, centralized team to run this kiosk experiment across their applications. On the other side, I've seen Amazon, where I've worked, kind of talked to a couple of colleagues there, and the way, I mean, the philosophy they have is what you build, you own it, and
Yep.
your team run those experiments
Yep.
throughout, you not only through development but also in productions, because you're gonna
Yeah.
do it. So
The
yeah, there
proper
are
SRE mentality. Yep.
I would say there are trade-off in both approaches. I mean, no, as an architect, as usual, one is no one is right and one is wrong. I think it's what basically makes how mature is your organization. Um,
Mm.
you're starting probably uh, in a small mid-sized kind of organization. Maybe you can specialize a couple of folks running these kiosk experiments in production, train them, and kind of decentralize into these different teams. Maybe that's one way to start off. So yeah, there are different approaches. I still have no golden answer for that. But yeah, I've seen different ways of doing this, and at the end of the day, it's what works for you matters the most.
Gotcha.
Uh, Coming back to your question, how you wanna get started? I think definitely there are a lot of tools available. I would say if you are with one of the cloud providers, be it GCP, be it AWS, Azure, start with the kiosk engineering tools. I think it's gonna be easy to get started for you.
Mm.
There's a kiosk engineering book by Mark as well. You can go through it. I think I can share those resources, which you can probably add it to at the end of the
Yep.
in your descriptions as well. I think that's another fantastic book, which will get in details of what kind of experiments you can, how you can structure it. But I would say it's easy to start with the cloud native tools if you are building a cloud native application. The other one, the community very popular, is Kiosk Monkey. I think you're gonna find a
Yes.
lot of videos, a lot of learning resources, and how to get started. I think that's this another tool. Gremlin is another popular one, which I spend up time on that. I think it's another very popular tool which you can experiment with. I would say more importantly is pick one of the tools. The concept remains the same. Try to
Mm.
master it, and then I think you can switch on tools depending on your business needs and where you are actually running things. So that's
Mm.
what my idea is. Um, I was speaking in one of the conference, QA community conference, I would say last month, and I brought this concept for them about this kiosk engineering, and these guys were very fascinated. I mean, they're doing performance testing, they're doing automation testing. Uh, I mean, it's not only developers who can do it; it's even the QAs or even the operational person can do this kiosk testing.
Yep.
If you
Yep.
haven't seen it. So it's another. I mean, who can do it? I mean, I would say it's
Open
developer
to
can do it
anyone.
out of the box, but yeah, I mean, even the ops and the QA people, I would say they can do it on the higher environment. So uh, I would say
Excellent.
that's how we can get started.
Excellent. Ashish, thank you so much for coming on and talking all about chaos engineering. I'm sure there's lots for people to start going and playing with and trying out. So appreciate you being here, sir. Thank you.
Thanks, Chris, again for this opportunity. It's again it was exciting, and feel free to reach on my LinkedIn profile. And if you have any questions, anybody who is watching this, I think I'll be glad to answer those things. Thank you.
Awesome. Thank you, Ashish. There we go, folks. So we have been learning all about chaos engineering. We started talking about what it is, how you might consider using it in some of those earlier phases of what you're doing, going from dev, or maybe even on your local machine, to dev, to QA, and to prod, that kind of prod-like environment, and thinking about the configuration of your infrastructure, thinking about the tests that you're running and that they're representative of the loads that you're expecting in production as well. And then ultimately looking at some of these tools that are available either within the community or from maybe some of the cloud providers, etc., that you are using day to day already. So with that, folks, it's been another great session here on Cloud with Chris. As always, if there's something you'd like to hear more of, please do let me know, get in touch. And otherwise, in the meantime, stay safe, stay healthy, and until the next one, bye for now.